Good morning, everyone. It takes me immense pleasure to welcome you all today. We have gathered here to celebrate the launch of Inspire, a mathematics club. We have chosen this day, that is 22nd of December, because today is National Mathematics Day. On this occasion, I am honored to welcome Dr. Manvendra Vashishta Sir, HOD of Applied Sciences and Humanities Department. Sir, I would like to invite you to speak a few words.
Yeah, thank you. Am I audible enough?
Yes, sir.
Okay. So, respected Dr. Avinash Kamble, coordinator of this event, and my dear friends, thank you very much for inviting me for this event. As you all know, National Mathematics Day is celebrated every year on December 22 on the birth anniversary of Sri Ramanujan and to honor his contribution in the field of mathematics. The main objective of this day is to raise awareness regarding the importance of mathematics in the development of the economy and welfare of society. The National Maths Day, which was started by former Prime Minister Economist Mr. Manmohan Singh on December 22nd, 2012, has gained significance among present time mathematicians, students, teachers, and main enthusiastic students. Various renowned mathematicians around the world have given quotes of highlighting the importance of mathematics in the world. To mark the National Mathematics Day 2020, I want to say only one thing. Mathematics is the queen of science, and arithmetic, the queen of mathematics. Thank you very much. Thank you very much.
Thank you so much, sir, for your valuable words. It's so nice of you to join us in your busy schedule. Ahead, I welcome all the faculty and students present here. I hope you'll have a great time ahead. Before beginning with the actual event, I would like to present a short video about Inspire. So now let's begin with the main event. We are honored to launch Inspire today on the occasion of National Mathematics Day. This day is celebrated to mark the birth anniversary of a legendary Indian mathematician, Srinivasa Ramanujan. We'll pay a tribute to Ramanujan and other great Indian mathematicians by delivering some presentations prepared by our students. So without wasting time, we'll begin with the presentations. I would welcome the first group presenting on the topic S. Ramanujan's early life and contributions in mathematics.
A fruitless year, take a fearless heart. One that blooms late will flourish in the dark. With this quote, I welcome you all today on the occasion of National Mathematics Day. Today, myself, Sakshi Chauhan, and my ally, Sakshi More, are here to bestow the exceptional journey and contribution of S. Ramanujan, the man who knew infinity. Srinivas Iyengar Ramanujan, also known as S. Ramanujan, born on 22nd December 1887, Erode, India. Untrained, self-taught genius. These are some of the adjectives that were used to describe Ramanujan's brief but incredible life. Born on this day in the year 1887, Ramanujan is a name to reckon among pioneers in mathematics. In 2012, former Prime Minister Manmohan Singh has declared his birthday, December 22nd, as National Mathematics Day. deep dive into his early life. Ramanujan was born in his grandmother's house in Erode, a small village about 400 kilometers southwest of Madras. When Ramanujan was a year old, his mother took him to the town of Kumbakonam, about 160 kilometers near Madras. His father worked in Kumbakonam as a clerk in a cloth merchant shop. He passed his primary examination and stood first in the district at Town High School, Kumbakonam, in 1898. He mastered his advanced trigonometry written by S. L. Loney at the age of 13 years. On the strength of his good school work was given a scholarship to the government college in Kumbakonam which he entered in 1904. However, the following years his scholarship was not renewed because Ramanujan devoted more and more of his time to mathematics and neglected his other subjects. This meant that he could not enter the University of Madras.
Now, let us have a look on his adulthood. He married at the age of 22. Ramanujan continued to develop his mathematical ideas and began to pose problems and solve problems in the Journal of Indian Mathematical Society. He developed relations between elliptic modular equations in 1910. After publication of brilliant research paper on Bernoulli numbers, he gained recognition for his work. He was later appointed as a temporary post as a clerk in the Account General Office in Madras. In 1913, Ramanujan wrote to G.H. Hardy. Ramanujan's letter to Hardy, he introduced himself and his work. In 1914, Ramanujan started his new life at Cambridge. So, here is the letter which Ramanujan wrote to Hardy. Now, let us have a look on Ramanujan's contribution in mathematics. He had contributed in various fields like infinite series, continued fractions, partition theory, number theory, magic squares, and also calculated Euler's constant to 15 decimal places. He worked on hypergeometric series and investigated relations between integrals and series, and many more such marvelous other topics which is still really helpful. Now, let us deep dive into infinite series. It states that if you add all the natural numbers, that is 1, 2, 3, 4, and so on, all the way to infinity, you will find that it is equal to minus 1 upon 12. Yes, it is minus 0.08333 and so on. The Ramanujan summation that was discovered in the early 1900s, which is still making an impact almost 100 years on in many different branches of physics and can still win a bet against people who are none the wiser.
What are continued fractions? Although there are far too many theorems to quote here, a few may suffice to convey the scope, the variety, the strengthness, and the wonderfulness of his work. When Hardy looked at these, he said, I had never seen anything like them before. A single look at them is enough to show that they could only be written down by a mathematician of the highest class. Clearly, these theorems played a crucial role in forming Hardy's high opinion of Srinivasa Ramanujan, which led to Ramanujan's coming to England and subsequently to his great fame.
Now, let us have a look on Ramanujan's partition theory. Ramanujan's one of major work was in partition theory. Using partition function P of n, he derived a number of formulae in order to calculate the partition of numbers. In a joint paper with Hardy, Ramanujan gave an asymptotic formulas for P of n. In fact, a careful analysis for generating functions for Pn leads to the Hardy-Ramanujan asymptotic formula. It had a remarkable property that it appeared to give the correct value of Pn, and this was later proved by Rademacher using special function, and then Ken Ono gave the algebraic formula to calculate partition function for any natural number n.
A number theory. He did a lot of his work in number theory. Number theory is
is a branch of pure mathematics devoted primarily to the study of the integers and integer valued functions. Further, he also worked on partitions, sum of squares, triangular numbers, and gave Ramanujan's tau function number theory, which is useful in cryptography. Cryptography is a division of applied mathematics concerned with developing schemes and formulas to enhance the privacy of communications through the use of codes. Life in Cambridge. On 16th March 1916, Ramanujan graduated from Cambridge with a Bachelor of Arts by Research. The degree was called a PhD from 1920. On 18th February 1918, Ramanujan was elected a Fellow of the Cambridge Philosophical Society that he would receive the greatest honor. His name appeared on the list for election as a Fellow of the Royal Society of London. The greatest honor that he received, his election as a Fellow of the Royal Society, was confirmed on 2nd May 1918. Then on 10th October 1918, he was elected a Fellow of Trinity College, Cambridge. The fellowship was to run for about 6 years. Ramanujan sailed to India on 27th February 1919. He lived extremely a fruitful period and his contribution is duly still recognized today.
Hence, we will like to conclude our presentation with a quote said by Ramanujan. An equation means nothing to me unless it expresses a thought of God. Thank you.
Thank you so much, friends. It was nice to hear you all. Now, I'll welcome the next group presenting on the topic Ramanujan's Magic Square. All the best, guys.
Good afternoon, everyone. Today, myself, Rushti Patil, along with Ritika Rai, Amar Hondra, and Numer Sheikh from Pillai HSC College of Engineering and Technology, are here to deliver a presentation on one of the interesting discovery made by Srinivasa Ramanujan, and that's Ramanujan's Magic Square. We all have heard about lots of discoveries made by Ramanujan, like Ramanujan Hardy number, Ramanujan's nested radicals, the Ramanujan's prime, the Ramanujan's theta function, partition formula, and many more. But today we are here to talk on Ramanujan's magic square. Now the question arises, what's the magic square? It looks like an ordinary square, but it isn't. This square is formed by great mathematician of our country, Srinivasa Ramanujan. The speciality of this square is that the sum of all the rows, columns, and diagonals is the same. What's so special about this square is that all the rows add up to give the sum 139. Here, if we add all the numbers in the first row like 22 plus 12 plus 18 plus 87, it gives the sum 139. Same for the next three rows also. As you can see here, the sum of all the columns also add up to give the sum 139. Let's have a look at these diagonals. They also add up and give the total 139. All the corners also give the addition 139. Here, as we can see, the sum of all the identical boxes is also equal to 139. It's also a fact that the middle square also gives the addition 139. Similarly, all these colored squares also add up to give the total 139. This clearly shows that if we sum the numbers of any four connected boxes, it gives the sum 139. Now, all might have question. Is 139 any special number? So, the answer is no. It's not a special number. Let's see in further slides why so. Apart from all the facts mentioned in the above slides, there's one more interesting fact about the magic square. Let's have a look at the first row. It says 22, 12, 1887, or we can say 22nd December 1887, and it's the birth date of a famous Indian mathematician Srinivasa Ramanujan. Now, it's possible to make your own magic square with your own birth date. Just we have to make a 4 by 4 table as shown in the figure besides. And these are the equations by which we can find the values in the magic square. Let's take an example with the birth date of the legend Indian cricketer MS Dhoni, 7th July 1981. It just requires two steps to make your own magic square. Step 1, just we have to initialize the value as x1 equals to 7, x2 equals to 7, x3 equals to 19, and x4 equals to 81. In step 2, now, by using Ramanujan square formula by substituting values of x1, x2, x3 and x4 in the equations, we obtain the remaining values. So, here's the result. This is a magic square with the legend MS Dhoni's birth date. Here the sum of all the rows, columns, diagonals, corners is 114. And here is the C program to draw magic square with your desired birth date. When we run this program, we have to just enter our desired birth date, like 22, 12, 18, 87, and it will create a magic square with your own birth date. So, here we conclude our presentation by saying that this was a great discovery made by Ramanujan Sir. We all should feel proud that India got a great mathematician like him. Ramanujan is also known as India's Archimedes for his immense contribution in the field of mathematics. These are the links we referred in forming this presentation. So now, it's a time to draw your own magic square with your birth date. Isn't it? Thank you.
Thanks a lot, Srishti. It was very interesting to listen to you. Moving ahead, I'll welcome Group 3 presenting on the topic History of Foundation of Mathematics.
Good day, everyone. So, I am Sami Ahmed, along with Rucha and Sakshi. We are going to discuss history on occasion of Mathematics Day. So, going to the history of mathematics, learning history of any subject plays a very important role, plays a very vital role, so that we get to know the origin and we get to know from where it is evolved, from where it is emerged. So we all will get to enlighten on this beautiful day. Let's move ahead to foundation. So, there are many excellent reasons to study the history of mathematics. It helps students develop a deeper understanding of the mathematics. They have already studied by seeing how it was developed over time and in various places. So, in broader sense, the mathematical investigation of what underlies the philosophical theories concerning the nature of maths. These are the contents we are going to discuss in our presentation: history of algebra, history of number theory, and history of geometry. Over to Rucha.
I am explaining history of algebra. Next. Let's take a look on concept of algebra. Basically, algebra is a branch of mathematics dealing with symbols. These symbols represent quantities without fixed values. We call them as variables. Next. So we might get question in our mind, how does the word algebra come? So, word algebra is derived from Arabic word al-jabr, and this comes from the book written in the year 1830 by the Persian mathematician Musa al-Khwarizmi. That book written on calculation by completion and balancing. Next. Evolution of algebra took place in 3 stages. First stage is rhetorical. It means problems were solved verbally. Second stage is syncopated, in which abbreviated words were derived to get solution of problems. And third stage is symbolic stage, which we are using today. Next. Now to know history of algebra, we have to go back in time more than 4000 years, shall we? So yes, here we are. In about 300 BC, Egyptian mathematicians solved linear equation with one unknown value. Egyptian mathematician Cairo Pyrrhus solved system of two-degree equations, but they have solved problem verbally and not used any symbol. Next. Over to Egyptian, Babylonian solved quadratic equation. They have recognized the positive numbers, rational numbers, and fractions too. But still, algebra was rhetorical. Next. Now, welcome to India in about 1818. Indian mathematician developed mathematical concept with the help of astronomy and astrology. Aryabhatta gave the digit 0 to the world. Brahmagupta discovered that the product of two negative numbers is positive. India is first country to recognize that quadratic equation have two roots. Also, they have invented decimal system, but they stated only steps and no evidence was provided. Next. Later, algebra is developed. Lowercase letters from the end of alphabets are used as unknown. It introduces linear equations, reciprocals, roots of power, limits, exponents, and many more. Next. So, we are thinking algebra is developed just to torture student in class, but no, it wasn't. Algebra is developed to solve real-world problems. Algebra simplifies problems so they are more easily solved. Algebra teaches you to follow the logical path to solve the problem. There are countless careers like teachers, scientists, computer programmers that require understanding of math and algebra in particular. If you want to do anything to improve technology, you need to understand algebra. Thus, the algebra plays an important role in our life. Over to you, Sami.
Talking about history of number theory. What is number theory? Next slide, please. So, a German mathematician, Carl Friedrich Gauss, from 1777 to 1885. He stated that he was actually the greatest mathematician since antiquity, and Gauss had an exceptional influence in many fields of mathematics, and he was ranked among history's most influential mathematicians. He said, mathematics is the queen of the sciences, and number theory is the queen of mathematics. Now, number theorists study prime numbers as well as the property of mathematical objects made out of integers. For example, rational numbers are defined as generalizations of the integers. Number theory or arithmetic or higher arithmetic in older usage, it is a branch of pure mathematics devoted primarily to the study of integers and integer valued function. Let's move ahead to the foundation. The most commonly used system of numerals is known as Arabic numerals. Two Indian mathematicians are credited with developing them. Very famous Aryabhatta of Kusumpura developed the place value notation in the 5th century, and a century later, Brahmagupta introduced the symbol for zero. The numeral system and the zero concepts developed by the Hindus in India slowly spread to other surrounding countries. The Arabs adopted it and then modified them. Next slide, please. So we are going to study. We are already studying these types of number system in general. So decimal number system. It has a base 10 because it uses 10 digits from 0 to 9. And in this system, the position is successive to the left of the decimal point. Binary number system. It has the base 2 and only 2 binary digits exist in this number system, that is 0 and 1. All of the computer and digital students should know what is a binary number system. So, octal number system. The base is 8 and it uses numbers from 0 to 7 to represent the numbers consisting in octal number system. Numbers are written or represented with base 16 in the hex system, and the numbers are first represented just like in the decimal system and later using alphabets. From 9, we use alphabets. Let's move ahead. So basis of number system. The number system that we use today is a place value decimal system. So now let's take a look at example, a number 536. This incorporates 3 numerals, 5, 3 and 6. But because we use a place value system, 5 does not stand for just 5. It means it's 5 of hundreds. And the 3 stands for 30 because it's in tens place. And the 6 is the only unit. Next slide, please. Evolution of number system. Summer was the birthplace of writing the wheel, agriculture, the ark, the plow, irrigation, and many other innovations, and is often referred to as the cradle of civilization. Alphabet number system came from Phoenician around 950 BC. It contained about 600 of symbols. Romans used their mathematics for more practical purposes such as building roads, bridges, and temples of stone. And coming to India, Hindu-Arabic numeral system can indeed be termed as one of India's greatest contribution to the world, since many of the countries adopted the Indian numerical system. Over to Sakshi.
Coming to history of geometry, beginning about from the 6th century, the Greeks gathered and extended this practical knowledge, and from it they generalized a subject known as geometry. From the combination of Greek words geo, that is earth, and metron, that is measurement. So, foundation of geometry are study of geometries as axiomatic systems. The term geometry can be applied to geometry, but often used to mean Euclidean geometry studied from this point of view. So, here we will discuss about the father of geometry, that is Euclid, sir. Euclid is often referred to as father of geometry as he wrote the most important and successful mathematical textbooks of all time, the Stoicheion or Elements, which he represents the accumulation of mathematical revolution which had taken place in Greece up to that time. Euclid's vital contribution was to gather, compile, organize, and rework the mathematical concepts of his predecessors into consistent whole. Later, it became known as Euclidean geometry. In Euclid's method, deductions are made from premises or axioms. So, here we will see some real life implementations of geometry. Geometry is used in almost each and every aspect of our life: nature, technology, homes, architectures, arts, sports, designs, CAD, that is computer aided designs, mapping, medicines, and many more. Here are some of the references we have taken from internet. So hereby concluding the topic, we would like to conclude our topic that now we know how important it is to have awareness about history from where it all began. All of the modern mathematics wouldn't be possible without it, as everything has its own foundation. Mathematic foundation is the reason we have this advanced era we are living in. Thank you.
Thank you, friends. A worth listening presentation. Well done. Now, welcoming the fourth group presenting on the topic Contribution of Indian Mathematicians. All the best.
John von Neumann once said that if people do not believe that mathematics is simple, it is only because they do not realize how complicated life is. And oh, what a thing to say! Today, we are here to help all of you believe in that very quote. We bring you a brief introduction to contributions of Indian mathematicians and the origins of mathematics in India. It's me, Sonali Gandharkar, and my contemporary Pavna Shetty, and we are here today to share with you all what needs to be shared. So let's dive right into it. Here's a brief overview of today's presentation. So, the first topic we're covering is Introduction to Mathematics and the origin and details of mathematics in India. Next, we have an array of Indian scholars that you'd love to know about, from Aryabhatta, Bhaskaracharya, Brahmagupta, and Varaha Mihir. So, let's start with the introduction. Now, as we all know it, mathematics is the science that deals with the logic of shape, quantity, and arrangement. And although it is abstract and theoretical, it plays a vital role in our everyday life. Because, let's face it, we are surrounded by mathematics. Now, moving on to the origin and details of mathematics in India. Well, mathematics has played a very significant role in the progress and expansion of Indian culture for centuries throughout the globe. Right from discovery of zero to the decimal system, it all originated right here. Let's start with the very well-known scholar, as we know it, Aryabhatta. So Aryabhatta, as we've heard, was one of the greatest Indian mathematicians and astronomers to exist. He is also the earliest Indian mathematician whose work and history are available to modern scholars of today. Using the Pythagorean theorem, he obtained one of the two methods for constructing his table of signs. He worked on the place value system using letters to signify the numbers. While he did not use a symbol for zero, the French mathematician Georges Ifraq argues that knowledge of zero was implicit in Aryabhatta's place value system. He also gave to the world the value of pi up to the first four decimals. There are many more works of his that are worth knowing. The next great name that we're going to learn about is Bhaskaracharya. Bhaskaracharya was also known as Bhaskara. The famous book Siddhanta Shiromani was written by him. He reached an understanding of the number systems and solving equations which was not to be achieved in Europe for several centuries. He acknowledged that any number divided by zero is infinity and that the sum of any number and infinity is also infinity. His work in calculus is something we all need to know about. Now the next great scholars and their work will be further explained by Ms. Pavna.
So now we all are well aware of the contributions by Aryabhatta and Bhaskaracharya. Now let's proceed with the presentation to learn about the contributions of other great mathematicians. Brahmagupta. He was an Indian mathematician and astronomer. He was born in 598 CE near present-day Rajasthan. He was a renowned mathematician and he contributed many important concepts like introducing the concept and computing methods of zero, was the one to invent the Fibonacci identity, and he also gave sine table and Pythagorean triplets. Further moving on, we have another renowned mathematician, Varaha Mihir. He was an Indian philosopher, mathematician, and astronomer. He is the author of Panch Siddhantika. His prominent work included the discovery of trigonometric formulas. He improved the accuracy of Aryabhatta's sine tables. He defined the algebraic properties of zero and negative numbers. He was also among the first mathematicians to discover a version of Pascal's triangle as we know it today. These were the contributions made by our great mathematicians which changed the history of mathematics. Contribution of Indian mathematicians is immense and extraordinary. From concept of zero to the modern concept of computational number theory, their input is noteworthy. The creative method of expressing every possible number using a set of 10 symbols appeared in India. It is important to state that the outstanding contributions made over many hundreds of years cannot be explained in few words without being familiar to the field of mathematics. Their contributions spread to Asia, the Middle East, and eventually Europe. In today's presentation, we highlighted contributions of Aryabhatta, Bhaskaracharya, Brahmagupta, and Varaha Mihir. But I would like to share that India's genius minds are not limited up to them. We also have many more great mathematicians from India like Srinivasa Ramanujan, C.R. Rao, Satyendranath Bose, Shakuntala Devi, and S.R.S. Varadan. Thus, I would like to conclude by saying that the contributions made by these great mathematicians has helped to make complicated things simple. These are the references which we have used in our presentation. Thank you.
Thank you, Pavana and Sonali, for an amazing presentation. I'm sure our audience have liked it too. Without wasting time, I'll welcome the next group, which is Group 5, presenting on the topic Capricor's constant.
Hello everyone. Today, on the occasion of National Mathematics Day, myself, Rishabh Mehta, and my partner Prathamesh Pandey, under the guidance of Dr. Avinash Kamble, are going to give you a small and minimal presentation on the topic of Capricor's constant. 71 years after its discovery, the Capricor's constant continues to fascinate amateur mathematicians and mathematics students. You might be wondering what Capricor's constant is. Hold on a bit and we will get to it. Let's start with its algorithm. Take a random number and just make sure that the number should not have all the 4 digits same, like 1111 and 2222. Now, for the sake of example, let's take 8352. Now arrange the number in ascending as well as descending orders. Subtract the smaller number from the bigger number, and the result in this case is 6174. Now, when we repeat the exact same algorithm with the new number 6174, we will get the same number and the loop will repeat. Now, doing any further iterations will give us 6174 only. Keep a note of this number 6174 for the further presentation. Let's see another example. When we start with another number 1432, after going through its algorithm once, we end up with 3087. And after continuing this iteration 2 more times, we end up again with 6174. Let's check out one last example. See this number 2008. This time, it takes 6 iterations or 6 steps to reach the exact same number 6174, after which this loop will continue with 6174. From these few examples, we can observe these two things. That is, first, 6174 is the end point of our calculation, and second, it is called the fixed point. This number 6174 is called as Capricor's constant. Now that we know that the number 6174 is Capricor's constant, let us look at Kaprekar. This Kaprekar's constant was discovered in the year 1946 by an Indian mathematician by the name D.R. Kaprekar. Born in the year 1905, he was a school teacher in a remote town of Devlali in Maharashtra. Kaprekar had discovered this number 6174 in the year 1946, but it took him 3 long years to be sure that this was the only possible fixed point. D.R. Kaprekar's name is also associated with many different properties of numbers. Besides Kaprekar's constant, there are Kaprekar number, self numbers, Harshad numbers, Kaprekar magic square, and many more. This number 6174 is quite remarkable, and that's due to 2 specific reasons. The first one being that whichever 4-digit number you start from, at the end of the iterations of this algorithm, you will end up with only one number, and that is 6174. Here, the only exception being the 9 numbers from 1111, 2222 till 9999, which have all the 4 digits same. Because if we apply the algorithm to them, we will always end up with 0 after the first iteration. The second reason being that the fixed point endpoint of 6174 will always be reached under 7 iterations, and we will always end up with the number 6174. Therefore, the maximum number of steps is equal to 7, while the minimum number of steps will be 1. Now, if we perform this algorithm on the number 2583, we will reach the fixed endpoint of 6174 in just one step. This is an example where we reach Kaprekar's constant in the minimum number of steps. While when we do the same algorithm with another number 3538, it takes us 7 iterations to reach the Kaprekar's constant. That is the maximum number of steps. These two were the examples of numbers which take each minimum and maximum number of steps to reach our Kaprekar's constant. Let's summarize what all we have seen till now. We had started with an algorithm and learned about what Kaprekar's constant is and why it is named after D.R. Kaprekar, and that is the number 6174. Then we had seen that it is only applicable to any 4-digit number, and to get the Kaprekar's constant, all we have to do is subtract the smallest combination of any number's 4-digit from its biggest combination. And following this method, we will reach Kaprekar's constant 6174 always under 7 steps. These are the resources which we have used for the research and preparation of this presentation or Kaprekar's constant. With this, I would like to thank everyone present here for attending this presentation. Thank you.
Thank you so much, Rishabh. It's time to welcome the last group for the day. Group 6 presenting on the topic Vedic Maths.
Good afternoon, all. I'm Shruti Vams, and the topic of the presentation is Vedic Mathematics, Some Interesting Facts. Did you ever hear about Vedic math and wonder what exactly is it? Vedic math is derived from the ancient Indian scriptures called as the Vedas. The Vedic math is very ancient, and it has many interesting tricks and facts which can help improve a student's ability to solve the given question. We will look through some Vedic math secrets that you can apply in your math problem solving. This should make you not only solve the questions faster, but also very efficiently. Vedic mathematics is the name given to the ancient system of the mathematics, which was rediscovered from the Vedas between 1911 and 1918 by Sri Bharti Krishna Tirthaji. According to his research, all of mathematics is based on 16 sutras or word formulae. For example, vertically and crosswise is one of these sutras. These formulae describe the basic way the mind naturally works and are therefore a great help in directing the student with the appropriate method of solution. Vedic mathematics is the form of mathematics that has been there in India from prehistoric time. Many saints and others, including Shankaracharyas, have contributed to this amazing mathematical idea, which is basically a large set of algorithms, so to speak, for simple and complex calculations. There may be more than that in Vedic mathematics. I'm no voice in the field. These simple techniques are just one proof to show how much people have used their brains when there were no pencil and paper and, of course, calculator. No wonder great epics and other things have stood for centuries. And why is it called Vedic? Well, Vedic comes from the word Vedas, which means the fountainhead of all knowledge. Also because the sources of the sutras were founded in ancient Vedic texts. According to the Supreme Court of India, Vedic means time factor. Vedic math is secular, which means anyone from anywhere in the world can practice it and take advantage of its results. These are the 16 sutras of Vedic mathematics. Vedic mathematics has many advantages. Let's see some of the examples. The first method is squaring of a number ending in 5. Let's find the value of 35 square. The number ends in 5, and so the square of it should always end with 25. In front of 25, let's place 3 into 4 equal to 12. That is the product of 3 and its consecutive number, which is 4. And you'll get the answer 1225. Now let us look at the longer traditional version for the same question, and yet we get the same answer. Let's take a 3-digit number now. Finding the value of 205 square. So as you can see in the solution, this trick works for the 3-digit number as well. The only condition it requires is that the number should end in 5. So now you may have understood why do we need to use Vedic mathematics. The second method lets you find the square of numbers between 30 to 70. In this method, we can find the square of the number usually between 30 and 70 within no time. Usually it takes us the regular multiplication method or the calculator to find the square of a number. Imagine if you can solve it in the mind in a fraction of few seconds. Step 1 is to find the difference between the given number and 50. You get 51 minus 50 equal to 1. In step 2, add the difference to 25. This gives 25 plus 1 equal to 26. And these are the first 2 digits. And finally, in step 3, the last 2 digits of the square will be equal to the square of difference, that is 1. And you get the final answer as 2601. Let's take another example. Finding the value of 64 square. Step 1 is to difference between the given number and 50. You get 64 minus 50 is equal to 14. In step 2, add the number 14 to 25. This gives 25 plus 14 equal to 39. And in step 3, calculate the square of the difference, that is 14 square is equal to 196. And you get the final answer as 4096. Method 3 will show you how to subtract any given number from 1000. In this method, for the given number that has to be subtracted from 1000, subtract the ones place by 10 and the remaining numbers by 9. For example, find the value of 1000 minus 356. For this question, we subtract 6 from 10 and 3 and 5 from 9, and we get this answer 754. Method 4 is about finding the cube root of a given number. In this method, you will be able to find the cube root of any given number within a fraction of few seconds. You need to value of cubes from 1 to 9 from finding the cube roots. Let's find the cube root of 2744. For this method, you need a confirmation that 2744 has a cube root. Once you are sure of it, check the last number, which is 4. Which cube in the list has this last number 4? As we know, 4's cube is 64. Now, cross off the last 3 numbers and the number remaining is 2, which is greater than 1's cube. So the answer is 14. Method 5 tells us how the division of numbers is made simple. For example, finding the value of 72 divided by 5. Here the number 72 is divided by 5. Observe the number 5 can be written as 5 into 2, 10, and 72 as 72 into 2, that is 144. And on division, we get the answer 14.4. The solution can be found easily within no time. Applications. One can solve any difficult equation in addition, division, multiplication, algebra, trigonometry, square root, cube root, only by mental calculations. Today's era is the fastest growing and ever-changing era. In competitive exams like CAT, UPSC, CET, GATE, JEE, and many other exams, Vedic math helps in faster mental calculations. In modern times, many researches are carried out in many universities of India and abroad on usefulness of Vedic math. Many universities have started courses based on Vedic math, yoga, and Vedic literature, which gain interest on Vedic subjects of students. Our nationalist Prime Minister Narendra Modi ji and HRD Minister Ms. Smriti Irani also took interest in Vedic formulae and yoga to make it popular in the world. Conclusion. A great deal of research is also being done on how to develop more powerful and easy application of Vedic sutras in geometry, calculations, and computing. The Vedic Mathematics Research Group published 3 new books in 1984, the year of the century of the birth of Sri Bharati Krishna Tirthaji. There are obviously many advantages of using a flexible, refined, and efficient mental system like Vedic maths. Pupils can come out of the confinement of the only one current way and make their own methods under the Vedic system. Thus, it can introduce creativity in intelligent pupils while helping slow learners grasp the basic concept of mathematics. So, we would like to advise all that we should learn Vedic mathematics, and of course, we should use it in our day-to-day life. This will help us all in fast competitions. These are some of the references that we used while making this presentation. Thank you.
Thank you, Shruti. A nice and interesting presentation. Yes, Vedic mathematics really amazes everyone. Thank you. Ahead, we'll be presenting some slides and information about some notable Indian mathematicians. Beginning with Sriram Shankar Abhyankar. Abhyankar is known for Abhyankar's conjecture, Abhyankar's lemma, Abhyankar-Moe theorem. He is awarded with Chauvenet Prize in 1978. His honors are Fellow of the Indian Academy of Sciences, Editorial Board Member of the Indian Journal of Pure and Applied Mathematics, and the Chauvenet Prize from the Mathematical Association of America. Next is Sharat Chandra Shankar Srikhande. Srikhande is known as Euler spoiler along with Bose and Parker. They spoiled Euler's conjecture. He is also known for Srikhande graph. His honors include that he was a fellow of the Indian National Science Academy, the Indian Academy of Sciences, and the Institute of Mathematical Statistics, USA. Next comes a very young mathematician, Akshay Venkatesh. He is known for his mathematical work and former child progeny. His awards include Salem Prize in 2007, Shastra Ramanujan Prize 2008, Infosys Prize 2016, Ostrowski Prize 2017, and the Fields Medal 2018. His honors include he is the second person of Indian descent to win the Fields Medal, and also he is the only Australian to have won medals at both the International Physics Olympiad and International Mathematics Olympiad, which he did at the age of just 12. Ahead, this is Manjul Bhargava Sir. He is known for Bhargava cube, Bhargava factorial, 15 and 290 theorems, and average rank of elliptic curves. He is awarded with the Fellowship of the Royal Society 2019, Padma Bhushan 2015, Fields Medal 2014, Infosys Prize 2015, Format Prize 2011, Cole Prize 2008, Clay Research Award 2005, and Shastra Ramanujan Prize in 2005. S.R. Srinivasa Ramanujan. Varadhan is known for martingale problems, large deviation theory, and he is awarded with National Medal of Science 2010, Padma Bhushan 2008, Abel Prize in 2007, which is equivalent to Nobel Prize in Mathematics, Steele Prize in 1996, and Birkhoff Prize in 1994. He has two honorary degrees from the University Paris at Marie Curie in Paris and from the Indian Statistical Institute in Kolkata. Next, Subhash Khote. He is known for unique game conjecture and is awarded with Waterman Award, Rolf Nevellina Prize, MacArthur Fellow, and he is also the Fellow of the Royal Society. His honors include Khote is a two-time silver medalist representing India at the International Mathematical Olympiad in the years 1994 and 1995. In 1995, Khote topped the prestigious Indian Institute of Technology Joint Entrance Examination. Madhusudan. Madhusudan is awarded with Gödel Prize in 2001, Nevellina Prize 2002, and the Infosys Prize 2004. His honors include that Sudan was honored for his work in advancing the line theory of probabilistically checkable proofs, a way to recast the mathematical proof in computer language for additional checks on its validity, and developing error connecting codes. In 2012, he became a fellow of the American Mathematical Society. Indeed, all these mathematicians are true gems of mathematics. It's so amazing to know about them. Now, we have come to an end of our National Mathematics Day celebration. But every end brings a new beginning. In the same way, we'll get back with many activities. I hope you all enjoyed the presentations and found it interesting. For giving the vote of thanks, I would like to invite Sanskriti Karasamble.
Thank you so much, Simran. It is my privilege to have been asked to propose a vote of thanks on this great occasion. I, on behalf of Inspire Club and the entire fraternity of management here, extend very heartily great gratitude to all the speakers and the team members for gracing your crucial work and sharing with your presentations. Thank you so much. I would also thank respected HOD sir for his presence and giving us his valuable time. We are all inspired by your highly lively words. I also take this opportunity to thank the entire technical committee and the reviewers for supporting us. Lastly, I would thank all the faculty members and the committee members for the hard work and dedication. The session was a great success because of these people. So thank you so much. Thank you. Over to you, Simran.
Thank you, Sanskriti. Thank you everyone for rendering your precious time. I hope we receive the same support for further events. For any suggestions and queries, please comment in the comment section given below the video. Thank you. Before ending with the event, I would like to speak something about Inspire. The students and faculty of Applied Sciences and Humanities Department, Pillai HUC College of Engineering and Technology, Rasaini, have initiated Inspire, a mathematics club. This club is dedicated to mathematics and its applications in tune with respective fields. The objective of Inspire is to gather students and give them a platform to show their skills in mathematics. We hope for your membership in Inspire so that we can provide you with many more activities. Thank you.